All right, welcome and thank you for joining our webinar today. Eyes wide shut. What do your passwords do when no one is watching? I love this one, you guys. It's going to be so fun. With Hacker Enterprise Security MVP and named last year by SC Magazine as one of the top women to watch in security, Paula Januszkiewicz. You're also joined by Beyond Trust Product Manager, Martin Kennard, who will run through an overview and demo towards the end of the webinar, so please stick around for that. My name is Sarah, your webinar host today. A kind reminder to please submit your questions via the chat box in the GoToMeeting console anytime throughout the webinar, and we'll cover your questions at the end during our Q&A time. Also, today's session is being recorded, and as attendees, you will receive a link to the recording and the slides shown here today within 2 business days from now. So at this point, I'd like to welcome Paula to the line. Hello, Paula. We're always very excited to have you on our webinar, so please jump right in, because I know you need all the time you can get.
Exactly. Thank you so much, Sarah, and hello everybody on the 2 days calls. Welcome. First of all, Happy New Year, and not to waste any more time anymore. You already, I guess, been on the seminars. If not, then of course my name is Paula, and I am performing a penetration test. I got also access to the source code of Windows, and I also speak at the different types of conferences, like for example Microsoft Ignite. You're going to also see me on RSA in San Francisco this year, so that's basically the speaking background. Also, if you did not try the quiz, 25 hardcore questions, please do. You don't have to register for anything, it's just for knowledge, so you are able to test yourself against that. 13 is an average right now, so if you're going to go anything above that, that's great. If not, then maybe you need to do it one more time. Just to mention, in March 27th to 31st, we're running the live workshop, the hacking workshop. I'm going to be delivering this one. It's in New York City, hacking and securing Windows infrastructure. So if you got some questions, go ahead and drop us an email, and we will send you, of course, all the details. Let's get into the subject, because it's actually quite an interesting subject. We're going to be talking about different types of passwords, or as we could maybe say credentials, that are within the operating system that are stored in a different ways. Of course, first of all, question is, what is a credential? Yes, and that definition that you see is the one that we have created in our team by thinking through in many different ways what credential actually could be. Of course, there is a long definition about what's that, but in general, from the technological perspective, that's some type of an information, some type of a data that allows the other guys to believe that you are who you tell you are. So that is the proof that this is you, and that is confirmed by someone else that the other party trusts. That's the credential. So credential can be coming in many different forms. Yes, it could be in the form of as we already know, a hash. It could be in the form of a certificate. It could be in the form of a password, etc., so that the other party is able to verify that. So when we think about passwords in the operating systems, there are plenty of ways those ones are stored in different forms. So password, maybe we should rather say credentials, because that's something that allows us to authenticate. So whether it's a password or something else, if we steal it, this is something that gives us an appropriate access. Long story short, we've got different types and places where the credentials are stored in Windows, and this is what I would like to talk about today. Let's start from something difficult before we get into an operating system's credentials, which is IIS. And what you see on the picture, it's an IIS structure, and IIS stands for Internet Information Services, and regardless the version, anything from IIS 7+, this is the infrastructure, a logical infrastructure of what we got inside. So we've got, of course, our application host config that stores all the settings, and at that point we've got also World Wide Web Publishing Service, so that's the one on the left, and Windows Process Activation Service, and that's the one on the right. The reason why I put P like this is because in the registry it exists under the WAS, which is kind of strange because it's not a Windows Activation Service, but that's how it is. And we have no other choice but to get used to it. So the whole situation when we are, for example, starting application pool, so user comes over, launches a website, server picks it up, http.sys picks up the request, it passes it to World Web Publishing Service, starts monitoring, and then Windows Process Activation Service launches. The reason why it launches is because of the two things. First of all, it needs to read the configuration. So why we are saying this? Because in application host config, which I will show you in a moment, we've got encrypted credentials of the application pool. So if Windows Process Activation Service is capable to read it, it means that if we're going to be or behave like Windows Process Activation Service, we should be able to do the same stuff. So that's the first thing that service can do. Second, it starts the process with chosen identity, the identity that it actually could read from application host config. So basically, if this guy is able to start the process as some user, for example, then for sure we are able to read those credentials. And now question, of course, would be how. And then at the end, we start worker process. We're not focusing today on the worker process, what is happening inside, though it's a subject for at least a couple of days of talking, though we are focusing today on application pools. Application pools in general are the ones that contain or settings or configuration of the application pools contains it also passwords, which we're going to be getting to, but it also contains configuration that is necessary for the website to start. So how could it be that worker process is started as a dedicated user even though we are not connected to the domain? Yeah, could be. Let's say I've got a web server and I'm going to take out the network cable and put it out, and I will try to locally run that particular application pool. Is it because of the cached credentials? Absolutely not. That's a different type of authentication. That is because of something else, and this is where we are getting during our demonstration. Okay, so the first demonstration is going to be like this. First of all, I will authenticate here to the machine. Yeah, so we've got a certain machine. And over here, what do we have? Well, first of all, let's get into our web server. So I'm going to just launch IIS. Here we go. That's the one. And over here, we've got different types of application pools. And these application pools, as you see, some of them, they run as application pool identity, and some of them run as a dedicated users. Yeah, so for example, I have here as well running ADRMS, Freddy Krueger, etc. Yeah, so basically, I got over here Freddy Krueger, and that configuration, always for the application pool, it's stored in the application in the application host config file. Yep. And when we get into Windows folder, then we've got our system32 and inet srv, and in config, this is obviously where it is. So if we do notepad application host config, perfect, and we search for Freddy, yeah, then over here, as you can see, we've got a Freddy Krueger with the password that is protected by IIS Windows Activation Service. So this is this P thing that I was mentioning before, only AS provider. AS stands for symmetric cryptography, of course. And this is, by the way, how this password is encrypted. Now, question is where we can find the keys that are able to give us this particular password. Yeah, and answer to that is also quite simple, and we will try to fetch this information in a moment. But in general, yeah, that is where and how we are able to see this password. First of all, this password, of course, it's encrypted, and we are able to decrypt it very easily, and we're going to do it like this. So when we get into C Windows System 32 inet srv, we run over here appcmd.exe, and appcmd.exe allows us to manage a web server to extract credentials from that area. So we've got over here one of the things, it's app pool, administration of application pools, and we're going to do it like this. CLS, appcmd, perfect. We're going to do list, because this is the verb that I have to add over here, app pool, yep, and then we're going to specify what's the name of the application pool. In this case, it's going to be app1, and then very weird switch, which you can read about in the help of appcmd.exe, is text, and then we put asterisks to display all the necessary information about this particular application pool. So enter, and very quickly, without waiting any longer, we have behaved right now as application Windows Process activation service, and over here this is the password that we have read directly from the configuration file, but as Windows Process Activation Service. Yeah, so it's really a matter of how do we ask. Either we open Notepad or we ask the IIS way. Yeah, so behaving in the same way as Windows Process Activation Service in order to read the configuration data of that particular application pool. Lovely. Now, question would be how these things are stored. Yeah, so what do we actually get access to, where those keys are, etc. Yes, that would be actually quite easy to answer. What we will do, we will actually over here start the process monitor and start to monitor the information. So let's basically do it. So capture, monitor the information when things are being configured. Yeah, so that we are able where these things are stored and are they stored actually safely. So we will basically go into advanced settings, and then when we've got our Freddy configured over here, we are able to maybe even override it. So it's going to be secure F Krueger. Okay, we got it. And the password, some kind of a password. Yep, here we go. Okay, and this is being saved. Okay, so we've got our identity being stored. Lovely. Yeah, so this is all stored. And now over here, we're able to spot where that actually took place. What am I monitoring right now, by the way, and that's quite interesting. I have a filter applied that category of the event is right. That means that out of 179,000 events, I am displaying only 79, because there were 79 right type of activity operations, so that we are able to spot, of course, what was happening here. And here, as you see, we've been indeed saving data, yes, into application host config file. As you see, inet mdr, and I have it configured so that it looks like it's on the network. So this is the case. So this is the shared configuration case for one server only. And over here, inet manager, so this is an IIS console, gets information from and creates a file into crypto RSA machine keys, because this is exactly the data protection API data for the local systems profile. Yes, and this is the place where we get the keys from. So if you ever wondered how these passwords are protected, they are protected because of those keys over here. Yeah. Now, question of the universe, is there a way and chance that someone is able to get access to this particular password? Answer is yes, of course. It really all depends, in this case, on the offline access. Of course, you need to have the appropriate tools to be able to combine those keys with getting access to that particular data in the application host config file, but that is possible. Yeah, that is absolutely possible. Okay, guys, so what we're going to do next, we're going to play with stuff that is related with IIS configuration as well. Let's cover this one, related with another case. So when we save the password in IIS, is it always that this password is going to be always saved in the same way? Well, no. Previously we had AS, so this time let's see, maybe there's a chance for another type of algorithm. So what we're going to do, this time I would like to show you the way, where and how the password is being stored in centralized certificates stuff. And it works exactly for centralized certificates in 2012, 2012 R2, and 2016, because it's the same mechanism. And the same story applies over here. We can do Control X to clean it up and start monitoring for all the right type of operations. And over here, I'm going to do Edit Feature Settings. And over here, I've got a private key password. And I'm going to specify some kind of a password. Yeah, here we go. And now, of course, the question is where this password is stored. And that password, if we have a look in the process monitor, is going to be stored somewhere. Yep, there we go. In the, surprise, surprise, this time registry. Yeah, so basically what we're going to do, so stop capturing. We've got over 100,000 events. And over here we've got something that's called private key password. I can jump to the registry. Here we go. Let's see. This one we're just going to close. Right click one more time, jump to. Lovely. And this private key password, it is nothing but base 64. And that base 64, we could be thinking, ah, that's going to be base 64. Well, this is bad news. It's not base 64 underneath. Yes, it's a base 64 for the encrypted value. And that encrypted value must be decrypted, but in this case, have a look guys, we are using RSA. Yes, so that indicates that that's going to be, we can even get deeper for the information because it's all the write operation. We didn't get into read operation, but in general, we are using over here asymmetric cryptography. Asymmetric cryptography means that we will need to get the encryption keys that IIS uses. And in order to be able to use those, we need to get into a very nice tool, which is in Windows, Microsoft.NET, Framework 64, and then we've got a version of Framework. Here we go, that's going to be this one. And then we've got here ASP.NET, and then we've got a tool _rec IIS, one of my favorites because it has a lot of different types of options that sometimes we don't even know about. Developers, they use it when they want to install ASP.NET, so with -i option. But if you want to do backup, for example, of the encryption keys of the IIS, which by the way most of the people forgot about, then here there is an option that is called PX, -PX. So this is export an RSA keeper to the XML file. So what we're gonna do? So here we go. So we've got ASP.NET rec IIS, and then we're gonna specify -PX, and then we're gonna specify in this case container, which contains the keys for IIS, which is called IIS was key. Here we go, and then we specify the file, that we're gonna be saving the keys to. And that particular file, it's going to be called text.xml. I get the same name in the script, so that will be perfect. Yes, text.xml. Lovely. And then we do PRI to export the private keys. Now, if we have a look, Notepad, this text.xml, how it looks, that is the value that we are looking for. Yeah, so that is the place where we are able to find the private key for the IIS, which will allow us to get access to the passwords. So what is the conclusion for now? Well, for now the conclusion is actually quite simple. When something is relying on the system profile, you've got an access to it offline, as long as of course you are able to have an offline access. And a reason why it's like this, it's because the system, local system account's password is stored in a registry. But before I reveal the mystery about how this is all protected and so on, let me show you this one. We're going to move to one more secret that is protected by the local system, and then we're going to, of course, explain the whole scenario. So we've got our notepad, and then second case, we need to run the PowerShell script in order to be able to get the password out there. First of all, what do? We get the content of the text.xml, yeah, so the one that we have already created. Then we create the RSA variable that will be an object for system security cryptography RSA crypto service provider. Why? How do we know that? Well, if we, for example, get a little bit more details in the procmon, we will be able to see that we are actually using for that asymmetric cryptography, as I was mentioning. That's why we're going to use this provider, because we know that in IIS, when the asymmetric cryptography is used, that provider in this case is going to be used. So we need to use here a little bit of knowledge, but the rest is easy. So we've got the first things over here. Yep. And then we read the stuff from the registry. Yeah, so we've got this one. So we read this key that I already showed you, this private key password. So we've got this one. Let me make it a little bit smaller so that we're able to see. Yeah, so we've got a private key password. Lovely. Yeah, okay. And this is the first one. And the second one, we will do a little bit of, well, I don't like the word magic, but this one is actually quite important over here. In Windows, when you play with cryptography, that's going to be quite simple, what I will say, but it has a very strong meaning. We are able, in our team, to spend over 6 months on working with a little tiny feature to be able to get access to that, for example, decrypt that string, etc. Because there are so many different types of combinations that are meaningful for you. One of the ways that is important is how do we read things, yes, or eventually how do we write things, but how do we read things in this case? So do we read it okay, from left to right or from right to left? That's why in this case here we have to reverse the array that we were able to get. This one, let's get one more time. Yep, okay, and then let's try to reverse it. Perfect, we got it. And then when we've got the array that is reversed, then we decrypt it, and then we, of course, display that particular value. And at the end, that password, being in a registry maintained by IIS, is able to be read in a clear text. Now, please don't get me wrong. IIS, it's not bad. It's really a matter of how things are safe in the operating system. So as long as we are aware that offline access or being an administrator could cause this kind of information to be revealed, yes, then we are able to mitigate appropriate solutions for that. Yeah, so it's really important who logs on to this particular server and who has access where. Yeah, and that's the first thing. Second thing is, of course, related with connection strings, because in connection strings password is in a clear text in a web config file, but that's something that we can also encrypt. Yes, it's really a matter who has access to that particular server. So this is another way how we are able to get the password from the IIS. Okay, so let's summarize that. We've been talking about the system profile. Now, is there anything more to have a look at? Absolutely. That slide, that is absolutely important slide to understand how credentials work in Windows. So we've got, of course, at the very beginning, something that is called a boot key. And boot key, well, we could simplify the explanation. It is from the system hive. Yeah, these are the class names, data, GPG, and so on, so the values that we've got over there. So these ones, yeah, they create a boot key. Boot key coming from system hive is the one that is indirectly decrypting different types of values. One of the interesting values on the list, it's some database and ntds.dit. How can we decrypt the hash? We cannot, obviously. Yeah, but I'm talking more about the situation where we actually decrypt the file and then we are able to get access to the particular hash. Yeah, so that's the case. To make a little bit more background, yes, that's something that looks like this. Yeah, so we've got some database, yeah, and in order to decrypt it, we need to get the boot key, we need to go through several operations, and then eventually we are getting access to MD4s, which is what Windows use for hashing. Yeah, so that's the one. Of course, some people say MD5, don't listen to them, it's not MD5, but MD5 is engaged in the whole process too. But eventually the hashes that are in a matter of our, like as a result of our password, created as a result of our password, they are MD4s. So when someone is in a possession of system hive in general, then this person is able to read a lot of stuff in the operating system. Now, things like LSA secrets, yes, in the previous videos with Beyond Trust, I was talking also about how to extract passwords from the server's accounts. Yes, so I will not repeat myself, but basically you can have a look. That is also the way how we are able to do it. So bootkey also does this, yeah, which I will prove to you in a moment for the some database. Now, another case that we've got is MSDCC2, so cache log on data. Even though they cannot be decrypted because they are stored as a value that cannot be decrypted, though we're able to decrypt to the certain point. The same with the hash. Can we decrypt the hash? No. And also hash or hash-based value is used for cache credentials, so cache log on data. It's a long discussion. And then we've got machine ACC, because, and that is the most interesting case, system hive, so the boot key, is also responsible for encrypting the local system's password. So local system account also has a password, and that password is the same, by the way, as the computer account's password. So if you're ever wondering why my SVC host, for example, communicates over the network, even though it is running as a local system, well, that is probably because the local system has the same password as the computer account. It's actually the one thing. So that is something that is worth paying attention to. Okay, now whenever we are thinking, of course, about the decryption of the SAM database and having System Hive in order to do it, how we are able to prove it? Well, we're able to prove it very easily. The only thing that we will need to do and have is, of course, SAM database. How can we copy SAM database? Well, many ways. Yeah? One thing is to create a shadow copy, but another way, we can also use the PowerShell, for example, to do that. Another way is to use the forensic tools to scratch the SAM database from the drive. So there are, in general, plenty of ways for performing this kind of operation. Yeah? Are we able to do it in general in the kind of a smooth way? Sure. What I have for you over here, it's another machine where we've got some security and system already copied. So what we're going to do, we're going to extract from that particular place hashes. So is it a very easy operation? Well, depends on the tools, of course, as always. Let's get into our tools. And then we've got over here CQ hashdump version 2. And CQ hashdump version 2 allows us to do some dump by specifying SAM. So where is it? SAM is in the C analysis backup SAM, because for SAM we have to have SAM, of course. And then we need to, as I already mentioned, have sys, so system, which is in the same folder, analysis backup system. Yeah, we got it. And then immediately, as you see, we've got hashes being extracted. So we do not need for that anything like security, etc. Yes, that is the whole scenario over here. Yeah? So security is useful whenever we need to extract a little bit different types of information. For example, service. Yeah, so that is also an option. CQ secrets dumper, and CQ secrets dumper as one of our tools. Yes, then basically we've got over here possibility to specify here security hive and system hive. So these two. And these are the ones that are necessary in order to get access to the secrets of the services. Yeah, so that is the way how we are. That is the type of information that we are able to extract from these two. So in order to get access to SAM, we need access to SAM and system. In order to get access to service secrets, we need to get access to, of course, system and security. Yeah, so different perspective. Okay, guys. So we've got that clear. Now, question is, what kind of other places we are able to get in the operating system for the credentials? And answer, of course, is quite straightforward. Are we able to get access to, for example, KeePass? Are we able to get access to remote desktop stored passwords? I'm of course asking another trivial questions, yes, because we could be wondering, well, we can always extract the password from the memory. Yes, but in Windows 10, that's not necessarily possible when we've got a credential guard implemented. But what is also interesting is that whenever we do not have credential guard implemented, then we are able to get access, for example, to the passwords that are from the hibernation files. And that's a little bit more interesting. So how do we do that from the hibernation files? Well, there are plenty of ways we can do it like this, but I have over here hibernation files that I have extracted from the operating system. There is not much about extraction actually, it's just enough that you're going to copy that. So I get a hyberfield.sys and I get a hyberfield for Windows 7, Windows 8.1. So there is a difference in between them. Maybe we should use Windows 8.1. Let's do it. So open 64. Why? Because I am opening right now that particular dump in the debugging tools for Windows. Yep. So we've got this one. Now Here we go. Symbols will be loaded in a moment. Lovely. Okay. The first thing I will need to do, maybe just quickly change the font so that everybody can see that. So we've got this one is good enough. Yeah, here we go. The first thing I need to do, because this is actually an operating system that is 64-bit, I need to change it to effective machine AMD 64 so that we've got a 64-bit processing in the analysis, and within the debugging tools for Windows from the hibernation file, so that it was originally the sys file, but I have converted this to the dump file with the converter. We are able to find it pretty much anywhere in the internet easily. Yep, I am able, for example, to perform the following. Yep, so here we go. Yeah, we're going to do over here exclamation mark process. Let's find 00 lsass.exe. So where is our LSAS? Yeah, so LSAS is under this address within the memory. So we're going to just copy this. So we've got Control C. Perfect. We're going to load our mimikatz.load mimilib. Yep, perfect. So our library for Mimikatz is already loaded. And then we're going to do right now .process /r and p to reload the symbols. Yeah, and to the certain address. We got it. And then exclamation mark Mimikatz, and that is basically something that allows us to extract the password, not trivial, from the hibernation file. Of course, as we know, hibernation file is nothing but the copy of the file that we've got in the memory to the disk. In this case, what we are able to see, let's have a look. Yeah, perfect. Oh, well, this is interesting, by the way. This is the computer account password. So that is also the password of the local system account. If you ever wondered how it looks like, there is a password, of course, and it looks like that. And over here, we are able to see, oh, perfect, the NTLM, or as you want, we can also call it NT hash, so the MD4 of the user's password hanging out in the memory. Yeah, in this case, we don't see the password, but we see the hash, which is more than enough to perform the pass the hash attack. Okay, guys, so this is perfect. Now, the next question would be, how does it look for the KeePass? Are we able to get access to the KeePass database? How does KeePass, what the KeePass rely on? Yeah, so what are the different types of options for the KeePass to be used? And for that, we will be actually using over here machine where I have, of course, whole KeePass configured. Yeah, so we're going to be playing with this one. Perfect. So let me, of course, get into that point, and let me show you the KeePass. So the users that protected certain database. And the question for us would be, are we able to get access to that particular database? And if yes, then how, of course. Yeah? So that's going to be our plan. KeePass is actually quite interesting because there are 3 ways how we are able to secure things. One of those ways is, of course, to use the or rely on Windows credentials. Another way is actually to play with master password, and that is actually a good way. And another one is to use the key. Yeah, so that is something that in both cases we should take into consideration. Now, let me of course show you when KeePass is good, when it's not good. First of all, KeePass is a great tool, don't get me wrong, but when you are in the domain environment, it really matters how do you protect your passwords. Okay, so here we go. We go to analysis. I got over here just a backup file, so I'm just going to delete it. Here we go. And then we get a CQBase. CQBase is actually something that is the user's database. So I'm going to just open it or try to open it. Yeah, and let's see. And then I get the possibility to specify the password. I'm going to specify the password that is called secure. And the reason why is because, well, you will see in a moment. And then it says that we are not able to open it because, well, the password is wrong. So that's it. That's the Freddy's database. And Freddy's database, it's in the Freddy's profile. Yeah, so if we go to users over here, and then when we go to Freddy, okay, here we go, users, then we go to Freddy, then we go update the roaming, then is KeePass, and that's the place, by the way, where user has something that is called protected user key bin, and that everybody has that uses KeePass. Yeah, so we've got this one, and then protected user key bin. That is actually the data protection API protected file that protects our database. Everybody has one. Yeah, so that's the real protector of your database. Now, I have taken this one and I have put it over here. So we've got this one in our analysis. Yeah, here we go. So we've got this particular key, CQ base, and then we're ready to rock. So what is important to have as well, it's the decrypted master key of the user. And that is not a very trivial thing, but the question is who can do it? Answer is anyone who is privileged in the domain. Anyone who is privileged in the domain. Why? Well, because the decryption value for the master keys of the users, it's not only the user's password in the case of a data protection API, but it's also something that we've got floating in the domain controller's memory. So whoever has access to the domain controller is able to perform this kind of operation. So let's have a look. We're going to take this particular key and we're going to use it in a moment. Yeah? So we've got here different tools. One of the tools that I'm going to be using, it's a CQ Data Protection API DB decryptor. That's the first thing. But we're going to actually start with the CQ Data Protection API blob decryptor. And that one takes a couple of parameters. Master entropy blob. Yeah. So let's run it. Master key is the one that I have right now in the clipboard. Entropy is the one that is actually a constant for KeePass, and the previous tool displays me this one. So this is an entropy that is used for the encryption of the particular this blob, this data protection API, this key. Okay, and then that's it. And then we've got blob, and blob is in C analysis, and then we've got our protected user key bin. Lovely. And out, that's okay, we can have it over here. So this 60, etc., that is actually, very important thing, that is actually our password, yeah, decrypted password, real password, that decrypts our KeePass database. Yeah, so let's move forward within the next operation. So we've got a CQ Data Protection API KeePass DB decryptor. Here we go. And this takes two parameters, yes, K and F. Yeah, this is also our tool, our team's tool. It took us a long time to actually discover that. To write a tool is quite easy, but to discover that it takes a long time. And then we specify K, and then we've got our decrypted key or password, call it as you want. And then we've got F, and this is a place where we specify analysis, and then we specify our CQ base, KBDX, so the database that we couldn't get access to. Yeah, here we go, because it's a user's KeePass database. Now successfully re-encrypted the file. Okay, lovely. So we've got a file that is created over here, and if I do click on it, it's going to ask me again for the password, but this time I know it, because by using this tool, our tools, we're able to put the password on it. So as you see, we've got secure, lovely, and then the database opens. Yeah, so that is the case that we've got over here. Lovely. So that is one of the ways how we're able to perform operations on that particular KeePass files. Same story applies to the remote desktop connections. Yeah? So in this case, RDG file is the one that you use for the remote desktop manager. Yeah? Are we able to decrypt it? Absolutely. In this case, you don't have much choice. Yeah, that is protected by your data protection API. So if you are a member of the domain, that is not a safe way to store it. Of course, it's a pretty still advanced operation, and the risk is not that big that someone's going to get access to those passwords, but that is absolutely possible. Yeah. Will I do that during the? Will I do it during the pen test? Yes, absolutely, I will. So what are we going to do? So we've got our tool, man decryptor, master, Yeah, we specify pink, and then we've got file, C, analysis, and then we specify over here our connections. Yeah, so we've got secure connections RDG file, enter, and then as you see, in this case, we've got this one. And in our case, couldn't decrypt the password, possibly missing decrypted master. Possibly this was a different master key that we will need to use. Yeah, so that is also an option, possibility in this particular scenario. Yeah, so but at least it gives us a particular master key that we could use for that specific operation. So we will need to decrypt that key in order to be able to get access to that particular data. Yeah? So if master key is wrong, or if it's not decrypted correctly, in this case it is actually decrypted correctly, but it's a different master key, then we are at least given information which master key we should use. So this is how, by the way, we are able to extract passwords in the operating system. Yeah? Summarizing, in a lot of cases, we rely on three things. First of all, data protection API that relies on user's password and Active Directory security. Second thing, we protect the secrets, the passwords, by using the local systems profile. Yeah, so that is the case. So anything relies on the local system, which means it relies on the offline access. It is accessible if you've got an offline access to the machine, or at least administrative access to the machine. And that's another case. And of course, whenever we are thinking about getting access to credentials, we've got another case, which is data protection API, but not for the system profile, but for the user. Yes. So user, we rely on the password and stuff that an Active Directory security. In a case of secrets, LSA secrets, hashes, etc., we rely over here on the local systems profile. And at the end, what is important is, of course, offline access that will eventually give data in case when we rely on the local systems profile. Yeah. So summarizing, our passwords are as secure as offline access is, as secure as user password is, and as secure as your Active Directory security is. So that is basically different types of places where we've got our passwords. Yep, so hopefully, guys, this time it was interesting as well. Don't forget about our hacking workshop that is happening in New York in March 27th. And for now, it's time for me to give stage to Martin so that you can listen about password management. Thank you.
Perfect. Thanks so much, Paula. All right, let me just find my right screen. Alrighty, okay. Hopefully you should be able to see the slide at the moment. So what I want to do is just take you a little bit around password safe and what it does specifically around some of the things that Paula mentioned, and just more specifically around PAM in general. So the password safe is really part of a set of products that Beyond Trust provides to lock down your PAM environment. So PAM is sort of typically passwords that are we would regard as privileged. So administrator, SQL Service, Oracle, root, anything that is just like a high privilege account, whether it's used to start services or whether it's used to be able to log in, it's like a super user account. So we provide a way and a mechanism to be able to lock down, rotate those passwords, the ability for people to be able to log on and access those credentials, say, give me the password for this account on this system. We also allow you to be able to, lock down services, so we can change the logon as properties of the services such that when they get changed, we'll rotate those service accounts, and also, we can restart the services as well. The A2A interface talks specifically to some of the things that Paula mentioned, so that there are some ways that we have of, allowing you to be able to remove those credentials from those files in the application pools, so that you're making API calls out to password safe rather than actually storing those credentials in there in the first place. SSH keys is another area, so it's you're as strong as your weakest link, and so ultimately what we allow you to be able to do is to make sure they're not only just your passwords, SSH keys, anything that gives a user access into your environment, we can rotate and we can lock down. In the case of SSH keys, we can automatically distribute them as well, so we can push your new public key out to the authorized keys files on your endpoint. And then session management uses all of those aforementioned credentials to log you on automatically. The cool thing about it, is it means that we never give out the password, and that's really the best password management system. You shouldn't give out a password. You just use the credentials to allow the user to be able to start a session, but what that also allows you to be able to do is to record what's happening. We can do real-time alerting, you can do real-time session monitoring, so you can look over somebody's shoulder, and we can also do real-time command blocking as well. So if you've got like a blacklist of commands that you want somebody to not type in SSH, then conditionally, it means you can kick them out of the session, you can just block the command nicely, or even just send yourself an alert, to say that someone's doing something nefarious, I need to be able to go in and look at it. Now, the way that the session manager works is, the user logs onto password safe, it sends down, it actually generates a unique key. That key is sent down to the desktop. Now, that's used for the desktop to access the proxy. Now, in all cases, we never send down the username, the password of the host down to the desktop because, ultimately all we need is really just this one key, which we're actually going to use to authenticate ourselves to the proxy using RDP, SSH, whatever native tools you use. So MSTSC, PuTTY, Reflection, MobaXterm, they'll all work. Now, once the proxy gets a key, it's then able to, identify, okay, this key is associated with this particular system and this particular set of credentials, and it will log the user on the inside. So it's completely transparent to the user when they got logged on. But the nice thing is, like I say, you never actually get a potential of credentials or anything actually coming down onto your client. By the way, there's no agent required, there's no client required, all you have is a central network component. One of the other things that we have is also, something to do with the API, and the API is a REST API. How this specifically works, in the case that Mr. Paula was mentioning, is we have a number of different examples where you can use the API to set up markers in text files. So essentially what happens is every time you rotate a password, password, say for example, rotates a domain account, the API can then extract what those credentials are and then update that text file with whatever the credentials should be. So, ultimately what you're doing is it allows you to be able to make sure that any credentials that are out there aren't stale, they're constantly rotated. We also have caches as well. Each of the caches will support the 6,000 requests per second each, and these caches are completely free of charge. You just distribute right, throughout your organization. So one of the other things that we also have is the ability to be able to control application access, and so that's let's say for example you're using ESX. We could be managing your vSphere credentials. We can log you on to your vSphere as a remote app. So it could be the thick app, it could be the web app. Ultimately, we log you on, you never see the credentials, and we're also recording what's going on as well. We can do exactly the same thing for Unix Linux. So Unix Linux allows you to be able to, to take any application and then we'll exec it. So whether it's just like a DBMS application or even just some simple shell scripts that you want a user to be able to run as utilities, this allows you to be able to run them, have the credentials played in, but of course more importantly we're recording everything that happens within that session. Now the other key thing is reporting and analytics, and that's really where I think that the biggest benefit of the product is, because we're not only just telling you that the type of things that you can do with the product, but we're also showing you how to manage it as well. Ultimately, you want to be able to see what's going on. You want to be able to scan your environment. You want to say, what's our security posture? How many accounts do we have out there that are vulnerable? I mean, how many accounts haven't been changed, for example, for over 90 days? You know, how many accounts are administrator that haven't been logged onto for maybe over a year? I mean, this allows you to be able to look for stale accounts, orphaned accounts, even backdoor accounts, you know, by looking at certain parameters. You know, we also do threat analytics. You know, this is all included with the product. You know, this is actually, you know, something we call Clarity, and it works across all of the Beyond Trust applications. So this allows you to be able to add some context to what the user's doing. So if it's the first time a password's used, first time logged onto a system, first time an application is launched, you know, these are all, you know, things that would elevate up a particular threat level. And so then we can actually start to hone you in on what's important. I mean, you know, most customers will actually use SIMs, and so we'll integrate with, you know, whatever you're using, QRadar, Splunk, RxI, you know, Sentinel. I mean, we have connectors that will allow you to be able to push the data out, but what we have is the benefit to be able to normalize that data within our application set, so you can actually use the content that's coming from our host-based tools as well as our network-based tools in order to be able to make a decision. So ultimately what makes this difference, you know, is first of all we got something called adaptive workflow control. It takes the context of not only who you are but where you are. So, you know, it looks at your IP address, and it will also, you know, allow you to be able to filter down what a user is able to do based upon where they're currently logged in. You know, we have full scanning capabilities, so we can find everything out about your systems, everything about the accounts, you know, right across the board, pull them in, and then analyze it, and then even automatically onboard accounts that are out of policy. You know, there's a full integrated data warehouse. You know, the analytics is actually built into the product, and then the smart rules, you know, really is something that allows you to be able to capitalize on the ROI. It's going to save you time because it will allow you to be able to automate a lot of the tasks, you know, of onboarding accounts, onboarding systems. All right, I mean, a lot of stuff you can do for the UI, you can do it for the API, but the smart rules allows you to be able to automate it. So that way, if you see an account that comes in, let's say somebody stood up a copy of SQL Server, we can automatically discover the SA account, we can pull it in, change the password, and then notify a set of users to say it's actually been done and onboarded. So, you know, it's something that allows you to be able to manage large sets of data very, very easily for minimal resources. Session management, live session monitoring, command blocking, that's no additional cost. That's all built into the product. And finally, I mean, really, it's just a product that's very, very simple and easy to use. I'm just going to show you a very, very quick use case, you know, just to kind of give you an indication of how the session management works. I want to access a system. It's simply a question of clicking one button. You know, I've selected a system, I've selected an account. All that's doing is that's just gone out, it's actually generated, you know, that one-time use key, sent it down to my desktop, it launched MSTSC, and I'm now logged into the proxy. The really cool thing, though, is everything that I'm doing is being recorded, and if I was logged on as an administrator, I'm able to actually see exactly what is going on within that given environment. It takes a couple of seconds just to come up here. Here we go. So here's the screen, and so what you see if I part that over there, everything that I'm doing on the screen, oops, I click a button, it is actually you know, able to be monitored. So everything, including mouse movements. Now, if something nefarious was going on, as an administrator, I can just lock that screen. That hasn't actually kicked the user out. What that's done is just stop the user from interacting with that RDP session. So, you know, if everything's okay, and, you know, you can customize this, put your phone number on, we can go ahead and we can unlock it, we can allow the user to continue, but it actually gives the administrator some central control that isn't potentially invasive to the user. You're not going to destroy stuff by killing sessions or killing SSH sessions. So anything that goes through the system, you got the ability to be able to log. So that's about it in terms of what I want to show you in this session. What I want to do is just actually pass it back over to Sarah now, just to run the poll, please.
Thanks, Martin. Okay, guys, we'll jump right into Q&A. Just if you would check your screen right now, based on what Martin talked about and really what Paula presented today, would you like to be contacted for a deeper conversation or a one-on-one demo? It'll be a personalized demo for you with a Beyond Trust security specialist. So if you select yes, somebody will be in contact with you and set up that demo and possibly even move you into a trial. So if you have any questions for Paula, please submit them now. Martin, a couple questions came in for you. Are there any limitations to the types of applications that we can use?
No, not at all. So any Windows application, any Unix, Linux application effectively. So the Windows application you run as remote apps, you know, and you use AutoIt scripts to be able to manipulate, you know, username, password, etc. that's being passed in. So any Windows application, including web pages as well, you know, you can use from that, and as I say, any Unix, Linux app as well.
We are implementing a dual account environment, Martin. Do you support the one-to-one mapping of domain user to domain admin accounts?
Yeah, absolutely. That's actually one of our specialities, because we can do that in a very easy fashion with basically 3 lines in a smart rule. It allows you to be able to associate a standard user account, you know, with their namesake account. You know, it should actually be their administrative account on the domain. So, you know, J Perkins will be mapped to J Perkins A or J Perkins admin or -A, whatever your nomenclature is. You know, we can automatically do that. And also, more importantly, we can map the permissions so that that user is the only user that has access to that account for accountability.
Okay, closing the poll now. Thanks to everybody who voted in that. And we have hit the top of the hour, so I'm going to wrap this up. A kind reminder, I did receive a bunch of questions asking about the slides and the recording. And yes, you will receive a link to the recording and to the slides shown here today within 2 business days from now. And it will come from our email alias communications@beyondtrust.com. So be on the lookout for that follow-up. And it will be sent to the email with which you registered for this webinar. A big thanks again to Paula and Martin. You guys, always a blast, a lot of info in 60 minutes. So we appreciate you guys getting through all of that. And thanks to everybody who attended live today. Have a wonderful rest of your day. We'll see you at the next one. Take care, everybody. Goodbye.